In this video, we are going to discuss, I guess to this side, solving exponential equations. And in particular, we're going to solve exponential equations using common bases. Okay, so this idea comes from this idea. Let's say I have this equation. B base raised to the x plus 5 power is equal to b raised to the 7th power. Well, what can we say if we know that much to be true? We got to know that those exponents are the same. So we can just say, if that is true, then x plus 5 is equal to 7, right? And that makes it very easy to determine that x is equal to 2. The other thing that you need to remember is when you've got a exponent raised to a power raised to a power, what do you do with those exponents? You multiply them. So a squared raised to the 5th power would equal a to the 10th. So those are the kind of two premises we're going to use to discuss solving exponential equations. So I've got a series of 6 examples we're going to walk through together. And we're going to start with this example. 5 raised to the x is equal to 625. Okay, so 5 raised to the x is equal to 625. We're going to look at both sides of that equation and see if we can write both sides with the same base. So the first thing you're going to look at is, can the larger number be written as a power of the smaller number? And if you know your powers of 5, you know that this is easily done, right? Because 625 is actually 5 raised to the, let's see, 5, 25, 125, 625, or 5 to the 4th. Which means that I can say 5 to the x is equal to 5 to the 4th. Like that, right? Well, if 5 to the x is equal to 5 to the 4th, we can equate our exponents and be done. Say x is equal to 4. Well, I know that once I substitute that 4 in, I have a true equation, so we're good to go. Move into the next example. 4 to the x is equal to 32. Well, let's look at these numbers, 4 and 32. Can 32 be written as a power of 4? Well, let's think about our powers of 4. 4 times 4 is 16. Times 4 again is 64. Oh, we skipped right by that 32, so the answer to that is no. So if that is the case, then we need to look at 4 and 32 and decide, well, is there something smaller that both of these things can be written as exponents of? Let's see, what 4 is a power of 2, and so is 32, so let's think about that. 4 is really the same as 2 squared, okay? And 32 is 2 to the 5th power. 2, 4, 8, 16, 32, okay? So we have something like this. 2 squared raised to the x is equal to 2 to the 5th. Now, using that power to a power thing that we just talked about, this can be written as 2 to the 2x. Right? And that means that now I can drop those bases and just equate the exponents. So 2x equals 5 and x equals 5 halves. Okay. Now, the great thing about these equations is once you get to this point, go ahead and sub it in your calculator. Take 4, use your caret button, raise it to the 5 halves, and you should end up right at 32. Okay. So now let's look at this idea. We have 3 over here. 3 raised to the 1 minus x is equal to 1 divided by 27. So numbers there should trigger this idea of what base. The base there is 3. Okay. So my left-hand side we just leave alone. 3 to the 1 minus x. Now that right-hand side, we know that the base is going to be 3. Thinking about just the denominator, what power of 3 is that denominator? oh, that's the third power, but since it's the denominator, we need to make it negative. So 3 to the 1 minus x is equal to 3 to the negative third power. So now I can, again, drop my bases and equate the exponents. 1 minus x is equal to negative 3. Adding a 1 to both sides gives me negative x is equal to negative 2, and x is equal to 2. Fantastic. Nice. Okay, so now we're going to move on to the second set of examples. We're going to start with these. 6 raised to the x minus 3 over 4 power is equal to 6, or I'm sorry, this is the square root of 6. Okay, so obviously our base is 6. That's easy. But how do I write the square root as a power, as an exponent? Well, we should know that anything under the square root is the same as raising it to the 1/2 power. So I have 6 to the x minus 3 over 4 is equal to 6 to the 1/2 power, and guess what? Drop those bases, equate your exponents. X minus 3 over 4 equals 1/2. And then, as you probably recall from linear equations, we can multiply both sides of this equation by 4 to get rid of our fractions. And I'd have x minus 3 is equal to 2. X then is equal to 5. Fantastic. All right, next example. We're looking at this one. 9 to the x power is equal to 1 divided by the cube root of 3. What do you think for our base? Looks like maybe 3. Okay. So 9 can be written as 3 squared. And the other one's a little tricky. Okay, so let's get this much so far, right? This 9 became 3 squared, and we still have it to the x power. This is 1 divided by the cube root of 3. First of all, do you remember what the cube root of 3, what power that is? Yeah, that's the 1/3 power. But when we bring it to the denominator, we need to make it negative. So we have something that looks like this. Let's simplify a little bit more. So we've got 3 to the 2x is equal to 3 to the negative 1/3. Then we're at a point where we can drop those bases. 2x is equal to negative 1/3. And then we can divide by 2 and get x is equal to negative 1/6. All right, last one. Well, we're done with this video. E to the x plus 4 is equal to 1 over e to the 2x. Well, obviously our base is e. But we want to write this right or left-hand side of the equation, right-hand side of the equation, it's a long day, as just e to something, not 1 over e to the something. Now remember that anytime you bring it to the denominator, it's just the negative exponent. So really this is saying e to the x plus 4 is equal to e to the negative 2x. And then, here we are, we're just going to drop our base and say x plus 4 equals negative 2x. Adding 2x to both sides, we get 3x is equal to negative 4, and x is equal to negative 4 over 3. Da, 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 da. And if you sub that into both sides of the equations, you'll get the same thing. All right, that's it for solving equations using like bases, and I'll see you soon.